Hello and welcome to the AHSS Guidelines blog. My name is Max Biegler. I work for Fraunhofer IPK in Berlin, Germany, and I'm here today for World Auto Steel to tell you about joining processes. And we're going to talk about life cycle assessment of welding processes. And I'm going to jump right in. What is life cycle assessment? Life cycle assessment is used to assess the environmental impact of a process. And with it, if you apply it to welding and joining, you can compare different joining processes in terms of their environmental impact. The whole process is standardized in ISO 14040. And here we're going to use an all-steel electric vehicle battery enclosure as an example. This enclosure has both resistant spot weld bondings and laser welds with and without filler wire. So we have some different techniques to compare. If we look at how to do such a life cycle assessment, we first have to define a functional unit. This is basically what we keep constant to compare across the different processes. So here we're choosing 1 meter of weld length to compare between the processes. Then if we look on the top right in the system boundaries, we're interested in assessing the welding process in the middle. So we have several inputs, electricity, filler materials, consumables such as gases, electrode caps, protective glasses. And then we have several outputs, which are, for instance, worn electrodes, and that these will go to the landfill. So we measure as much as we can in the process. For instance, at the bottom right, you can see that we measure the electrical consumption of the laser during welding and during the idle time before. And if we cannot measure something, we use databases to get good values for the life cycle assessment for the environmental impact of a certain item. For instance, of the extraction of copper or of steel for the filler wires. We're not considering second order effects. So for instance, material savings due to reduced flange widths are not considered. If you're more interested in the material side of an LCA, World Auto Steel and World Steel Association have a lot of published data on that as well. But here we're only sticking just with the welding and the joining process. So looking at results, the most important result is usually the global warming potential of a process. So that's the figure on the left. This is measured in CO2 equivalent. And here we're now comparing laser remote welding, laser wire with laser steel wire welding, laser brazing using a copper wire, and resistant spot welding bonding with 2-component and 1-component adhesive. And we're seeing that the largest contribution is electrical energy for the system. And then there's also a large contribution by compressed air to shield the optics of the laser systems. But this is also produced by electrical energy. And if we're going from laser remote welding to laser wire or the other processes in general, we will also have an influence of a filler material, so the wire or the adhesives. In fact, the adhesives have a larger impact in comparison to the wire because they're mostly made from chemicals and organics that release more CO2 when they're produced. The second impact category is for acidification, and I chose this one here because it makes a great point about the filler wires and the materials you use. We see that the processes are relatively similar, but only laser brazing stands out in terms of acidification. And this is because we use copper filler wire here, and copper releases relatively large amounts of acidic material during extraction. So here we're seeing really the impact of one change in the process, changing from steel or changing from an adhesive to a copper-based filler wire. One last thing to note here, if we're looking to become CO2 neutral with our processes, we have the easiest process to achieve this with would be laser remote welding, because we're only using electrical energy and compressed air, which is also produced using electrical energy. So if we had a CO2 neutral electrical grid mix, we'd be able to switch this process to climate neutral the easiest without looking at complex supply chains. So in conclusion, life cycle assessment enables the comparison of welding process environmental impacts. We can identify saving potentials because we have hard numbers and solid data, so we can compare and we can therefore also find out where to optimize a certain process. The main contributing factors are electricity and filler material consumption, and carbon neutrality is achieved most easily with a process that doesn't use any additional material. So in this case, laser remote welding. So with that, thank you for the attention. My name is Max Biegler here for World Auto Steel. If you have any questions, please feel free to get in touch.